This video is all about the difference between the tree and graphs. You might have heard these topics, these data structures of tree and graphs, but do you really understand what are the difference between these two? This video is important for all the students who are learning the data structure and trying to solve the problems of DS in tree and graphs. Approaches in both the data structure type of problems, we have different approaches, but it is important first to understand what is the difference between these two so that you can apply the techniques whatever you learned in each of these categories. So let's start. So in short, I'll explain what is tree. Tree is a data structure which has a node and its children, and there can be many children. Either it can be 0 or multiple. So given a node, this is tree. Even if there is nothing, null, that is also a tree. It has one node, then it is a tree. It has two nodes, then it is tree. But maximum allowed children if are 2 only, then this is a special type of tree called binary tree. But there can be n number of children in any tree. These are basically called n-array tree. So what definition you got? If there is null, that is also called a tree. If there is a node, then there is a tree. It can has its children, either 0 or multiple. If maximum children that are allowed in a tree is 2, then it is a special type of tree called binary tree. And if multiple children are allowed, then it is called n-array tree. There are multiple data structure which emerge out of this itself, like segment tree, KD tree. So trees is a very vast topic, but here what we are trying to understand first, what is tree. Now let's take a look at the definition of graph. Again, null is a graph. Having a single node is also a graph. In a graph, a node can have children, and it can be any number of children. So this is also a graph. Can we say this is a tree? Let me know in the comment section what you think. This particular part is tree or not. See the definition. There is a node. It can have children. So this node has two children, and this particular node again has children. So this is a tree. But what makes the difference here? In a tree, it is always directed. So there is a parent and child relation. Through parent we can reach to child, but reverse is not possible in a tree. Whereas in graph, it can be directed as well as undirected. So if 1, 2, 3 and 4, if from 1 we can reach to 2 and 3 only, that is means directed, then it is a tree. But if it has become a bidirectional, then it is not a tree, it will be a graph. And the difference which lies is graph can have cycle. So for example, this is a graph but not a tree because it has a cycle. Whereas in any tree, there cannot be any cycle. Even in n-array tree, you can reach from parent to child, but to its further child, but it cannot move to parents. Though there are special type of tree like which can have the parent pointer, right? But those are modified kind of tree. It's not come in a category of graphs. And in terms of terminology, we called these nodes and root node for the top node, and then we have children's, right? And these are called the basically edges to the children, right? And in binary tree, we use the terminology left child and right child, whereas in n-array tree, it will be an array of whatever the size. In graph, we have vertices or nodes, and then we have edges. So this is the main difference between the tree and graph. Now let's take a look in the definition of the nodes, how the graph is represented and trees are represented. Trees are represented through a class called node. There are different languages like JavaScript, Python, C++, Java. They have the different syntax, but here I am just writing the pseudocode. So let's say there is a node, and node can have value, basically whatever is value is existing in the node, then left child or the right child. These are again the node's reference, and this can be of any data type like integer, float or string, whatever you want to store in these nodes. Now this is a one definition of one node. In a basically a tree, you will be given the root node only. Then through that you can traverse its children and further down the line. And when we say traversal, it can be like there are different types of traversal, which like in order, post order, pre-order or level order. So if you want to know more about these traversal, please let me know in the comment section. I'll create a separate video on the traversal of tree. Now let's take a look at the graph, how graphs are represented. As we have discussed, there are nodes and there are edges. Nodes can be n number, whereas edges can also be many. Even there can be multiple edges in a graph. So for example, this node is connected through this edge, again then this edge, again this edge, right? There can be 3 edges, whereas in tree this is not allowed because it is forming a cycle, and as it forms a cycle, it moves out from the definition of tree. So to represent a graph, we have 2 different ways. One is matrix form. So on the rows we can have n number of nodes, right? And here also we can have nodes. So U node is connected to V node or not, then its value at that cell will be 1 if it is connected. And these nodes can show that there is a connection or not. Also some other parameter, for example the weight between these nodes. So let's say in U node and V node there are 3 nodes, 3 edges which are connected, right? So there will be, let's say 3 that we can show. Or if it shows weight, right, let's say WT1 and WT2, given it is not multiple edges connected, then in this particular graph we can show, let's say U, V and W. Then between U and W, the weight is WT1, between U and V, WT2. So this matrix can show either the connection or the weights between the edges, between the 2 nodes, weight of a edge. we can show the graph. We can represent basically the real world problems in a graph. For example, there is a pipeline connection in a city. Water pipeline is going through different houses, through different water bodies. This can represent through a graph in a computer. When we store that information, if there is a edge between the two nodes, here the node can be water body or any house or any water storage facility. And again, if we need to show the weights, then that the capacity of that pipeline can be represented through weight. This is one way. Other way is called adjacency list. In the adjacency list, what we have, it's a map of node to a list of node. So let's say we have few nodes U, V, W, X. Now if U node has a connection with, let's say, W, then it will have one edge. Basically that list will have W. And if it also has, U has a connection with V also, then V. Similarly, now U has a connection with V, so this particular field will also have a list with U, and W will also have a list with U. And let's say X is not having any connection, then its list will be empty. This is called adjacency list. This type of representation helps in saving the memory because we are not storing all the nodes. It will be n square memory is required if n is the number of nodes, because we are representing a connection between every two nodes, even though there may be no connection. Whereas in this, it will store only those edges which has a connection. So it is memory efficient. So I hope you got the difference between the tree and graphs. You understood how these two different data structures are represented. If you have any question, please let me know in the comment section. I'll happy to answer those questions and clarify your doubts. And if you want any other topic on which video I can create, please let me know. I will be happy to create and clarify all the doubts in those topics. With this note, I'll take a leave. Thank you.